This is the demonstration video for the ioport controlled USB application. In this application, we can read, write or set the data direction of a input-output port of ATmega32U4. At device end, we have one LED connected at PB4, pin number 5th of the port B, and at pin number 1st of the port D, which is PD0, one pull-up resistor and one pull-down resistor. The input-output port of the ATmega32U4 can be accessed using the host application. The host application is built on Python programming language. It can be run on Ubuntu Linux or any other equivalent distribution. For running the Python application, we need to run the command sudo python application name. In the host application, we have two options. Option 1, through which we can define the port direction of a port, and option 2, through which we can access a port, that is, we can read or write a port. First, we will define the data directions for port B, port F and port T. At port D, PB, we will define the PB4, which is the pin number 5th of port B, as output pin, and PD0, which is the first pin of the port D, as output pin, and pin number 8th of the port F, which is PF7, as input pin. So option 1 to define port direction. Now we need to enter the port name. First we will change the port direction of the port B. Now the hex value for the data direction. We will make the PB4 pin as output pin and all other pin as input pin. So the equivalent hex code is 0x. PB4 as output pin means 1 needs to be write to this value. So data direction for the port B is updated. Now changing the port direction for port F. So we will make the pin number 8 of the port F as input pin. So the equivalent hex code for the making the pin 8 of the port F as input pin and all other pin as output pin is 0x7F. Port F updated. Now we will make the port D pin number 0, pin number 1 of the port D as in output pin and all other pin as input pin. The equivalent hex code for the pin 1 of the port D as input pin and all other pins as output pin is 0x01. All the ports are updated, port D, port B and port F. Now we will access these ports. For this we need to get back to the previous option. Now accessing the ports. First we will write a port, option first. First changing the pin number 5th of the port B, which is PB4 as high. So making the pin number 5th of the port B as high, the equivalent hex code is 0x10. So this is the pin number 5th of the port B, PB4, which is now high. So the red LED glows because it is connected to the PB4. Let's make it switch off again. We will make the PB4 low now. Okay, it's low now. Now we will make the PD0 high, which is the pin number first of the port D. For making the pin number first of the port D high, the equivalent hex code is 0x01. So the green LED glows now, which is connected to the pin number first of the port D. Again making the pin number first of the port D low. Okay, by mistake I set the value for the port F. Okay, it's off now. So we have successfully made the one pin of port B and one pin of port D high first and then low. Now we will read a pin for the port F, which is pin 8th of the port F. The pin number 8 of the port F is currently pulled up through the pull-up register. This wire is connected to the pin number 8 of the port F, it is currently pulled up. Option 2, to read a port, we need to enter the port name, which is F. As we can see, the read output is 0x80. 8 indicates that it is the pin number 8th, which is PF7, that is high. Now we will pull down this pin and we'll read it again. So the read output is 0x0, which means all the pins are low. So this was the input output port application. Through this application we can set the data direction, read or write a port. This can be done using a host application. Please use the links below for more information. Thank you.